Hello and welcome to Centrify's video Chalk Talk series. This is a series where we take a more in-depth dive looking at our technologies and how our customers benefit from these technologies. And today with me I have Paul Moore, he's our CTO, and I'm David McNeely, Director of Product Management. Today we're going to be talking about Smart Card, and this is actually part two of a two-part series on Smart Card, where in the first part we talked about basic overview of Smart Card technology, sort of what the benefits are, why people would want that. And today we want to talk more in depth about the architecture. More specifically, we're going to be talking about Smart Card login to Macintosh and how that works tied into an Active Directory infrastructure. So Paul, one of the first things we wanted to talk about was how does Smart Card login work on a Macintosh? Do they provide that kind of capability in the operating system? Is there something that we needed to do to make it work better with Active Directory?
So the current, as Apple ships in the Macintosh, there is some smart card support built into it. It's useful in some areas, but it's fairly simple. It certainly isn't very well integrated with Active Directory, and of course, it's definitely not integrated with our DirectControl product. So the features that they have is with smart card support is more to do with enabling you to use those smart cards as a way of interacting with your email client to let you sign your email and so on, rather than being focused on controlling your authentication to the operating system when you first log in. Whereas we wanted to enable you to use it both for the email signing and so on, but as well as logging into your machine.
Okay, so that sounds like they've already built some of the more basic plumbing pieces to enable like the simply smart card recognition, the screen dialogues for PIN prompting, that kind of thing?
Yes, so that's very fortunate for us, is that we can take advantage of a lot of the infrastructure that Apple has implemented, and we can simply build our stuff on top of that rather than having to implement that ourselves. That would make our life much harder if we actually had to do all of the nuts and bolts of the smart card support, because that's a very diverse infrastructure we would have to deal with.
Right, so Smart Card, actually Microsoft already supports Smart Card login into Active Directory, but is there something else that we needed to do on the Macintosh side? Given that we know it needs a little bit more information than a typical Windows machine, but somehow there's this process that has to take place for a user to log in, and can you tell at a high level how that works? Or?
So I think it would be better if I was to draw you something, right? Especially as these
that would be good.
These are talk things. So actually what I'd like to do just first of all is just talk about some of the infrastructure that Apple has created for supporting smart cards on the Mac, and then looking at how we take advantage of that, and then we can talk about how that interacts with Active Directory. I think that'd
be great.
Yeah. And although it says Chalk Talk, we're actually using much more modern technology, which is the whiteboard. So I'm going to just talk about, first of all, the components of the smart card infrastructure that exist on a Mac. Yeah. So you're going to have to forgive my artistic capabilities. So this is a smart card reader here, and this is a smart card. So the first thing you've got is some hardware driver here that's responsible for communicating not with the smart card but with the smart card reader. This is typically going to be a USB port. Theoretically, it could be built into the Mac, although I don't actually believe there are any Macs with smart card readers directly built into them.
Not today.
It could be a serial thing. There are also, contactless ones and so on. But fortunately, we don't have to worry about that. That's something that either the smart card reader vendor or Apple themselves, as I said, almost all of them are USB connected devices. The Mac then uses this piece of software here called PCSC, which stands for Personal Computer Smart Card Support, and that is a daemon running all the time that is monitoring smart cards being connected to the system. And its job is to then, when a smart card gets plugged in, it sees that happens. It queries the smart card. There's an identifier on the smart card that says not only it says who made it, the model, and also a serial number.
Right, the ATR.
Exactly, the ATR sequence. And this smart card subsystem on the Mac, again, we're still talking about Apple's bits here, has a lookup table that tells it an ATR that looks like this, is this type of card, and so on. And what they end up doing, again, when I say they, I mean the Mac, is they end up loading a thing called token D. Now, token D isn't a thing, like there's one token D. What that means is there's a token D for each different type of card. So there'd be a token D that supports, let's say, the federal government PIV card.
Right.
There'd be a token D that supports, Exalto's .NET card version, whatever. One for each type of card, and it's the PCSC process is responsible for working out which type of card it is, and then it launches the
right.
next.
And if I understand right, the token Ds were designed specifically for each of the cards and how they were provisioned. So, this may be a Schlumberger or an eGate or Gem Plus card, but depending on how it was provisioned, it might be a PIV card, it might be a CAC card, and that determines which token D.
There's actually two things going on inside. We could, of course, do a whole week's worth of education based around how smart cards work, how they get set up, the different ways they get used, and the capabilities they have. But the way to think about it, how I'd like to think about it, is that think of a smart card as like a hard drive. There's two things you need to think about for the hard drive. The first thing is, what type of hard drive is it? Is it an IDE or a SCSI or whatever? In other words, you need to deal with the basic capability.
And that's what this would care about.
Actually, I was not even thinking about that. I'm thinking about as the card, I'm thinking about basically what type of card is it, in the sense of at the very low level, how do I talk to it, right? And then on top of that, there's a thing of saying, well, how is that drive being used? Is it being formatted as a Solaris file system, or is it formatted as an NT file system or a Mac file system or whatever? So it's the same card, but it can be formatted in a different way, in what you call provisioning. That's typically what it's called. But in other words, the card is set up in a particular way with data configured in a particular way. And a token D is aware of both issues. It knows what type of card it is, in other words, what logical commands to issue to it, and also then where the various pieces of data that it cares about are logically located in that. And just to get back, I'm saying pieces of data. I mean, what we're specifically talking about is keys, cryptographic keys, and the digital certificates, which are on there. So the token D, this token D needs to know how to enumerate the certificates on there, needs to know where the cryptographic keys are on the card. So yes, you can imagine, for example, a token D that is for a Schlumberger PIV card. Except it's not Schlumberger anymore; it's Exalto, but that's
Gemalto now.
Yes, Gemalto. Yes, fast-moving industry. Anyway, so we plug in card type X, token D type X loads, and all the token Ds expose a common interface to a piece of software. There's a large subsystem in the Mac, which I'm just going to call the Security API, which is Microsoft's Apple's own API within the environment, and some of those APIs are actually provided by the token D. So this is an API used by lots of components of the operating system, lots of applications within the Mac that need to do various security things, such as enumerate certificates, perform cryptographic operations, and so on. There's a kind of superset, not a superset, layered over the top of that, is a thing called the Keychain API. Keychain API is very focused on certificate management and so on. And so that actually uses this API as well. So one of the applications you'll see on the Mac is an app called the Keychain. And this is actually, when you're using a smart card on that position, you're trying to troubleshoot a Mac, that one of the first things you'll do is plug the card in, fire up the Keychain application, and see if the card actually appears in the keychain. If it doesn't appear here, then some link in this chain is broken, and you should not attempt to get any further to do any logins using it, or fire up your email application to try and use it. So you'll see. So the keychain application is in fact just an application calling those APIs. It doesn't. There's nothing. It doesn't have any special privileges there. So you can imagine another application, such as let's say the Thunderbird email client or Safari browser or whatever. Will use this API and possibly this API to allow it to perform like signing things, enumerating certificates, and so on. And DirectControl, up until now we haven't discussed any code written by Centrify. This is all Apple's standard code. So here this is DirectControl, which is our software, and that is using both the keychain API and the security API directly to interact with a smart card.
Okay.
In a second, I'll talk about the kind of information flow and how AD is going to appear over here. But what that means for a customer is, first of all, they don't need to know this. This is kind of, it's interesting to know, but it's not actually necessary to know this. But what it does mean is, if you want your smart cards to work with our smart card support, the thing to do is ask your smart card vendor, do they have a token D? Because this piece of software here is supplied by the supplier of this piece of technology.
Right. And we talk about CAC and PIV. Those are common, right? As far as we understand on the standards, it seems like there's.
So CAC is the Common Access Card, which is a military smart card, which is a well-defined format, and so there is actually shipped in the box of the Mac since 10.3, certainly 10.4, is a token D that drives the military CAC. A more common one that is happening now in the not just the military but federal generally is called the PIV, which is kind of a follow-on to the CAC, and that's not only for military personnel, but it's for all federal employees as well. I believe that 10.5 was or does, I don't recall. Do you know?
I'm pretty sure 10.5 supports
has a PIV token D directly in it. We've also done some work, as you know, with some partners as well, other smart card vendors, and it's been quite a pleasant surprise to find that they install their token D, we plug a card in there, and it all just works, which is which is nice.
Like the .NET cards.
Yes,
from Gemalto.
Yes, sorry, Gemalto. I've got to get the name right. But what we're saying is, as long as they support this interface here, they supply this module, the rest of it should just work.
Okay. So smart card login. Now, Apple has said that they do smart card login, but as I understand it, it seems like their smart card login means that they would exercise the code that you've drawn here and be able to log in locally, but it doesn't seem like it didn't enable you to log on to Active Directory.
Correct.
To enable single sign-on to other AD integrated services.
So what Apple actually has been providing since 10.4 certainly was the ability to log in using your smart card, and their login application, the thing that does the graphical login, would detect that the smart card is inserted, and what it would do is they actually had two modes that it could operate in. One was it looked to see. It basically said, do you know the PIN of the card that you've just inserted? And if you did know the PIN of the card that was just inserted, and the username that's on the card corresponded to a username that the machine knew, then you would be allowed to log in, which is okay, but fairly weak mechanism. There was another mechanism you could use whereby an administrator of the machine would take like a serial number off this card and put it into a local database on the machine, or could be in the Mac central database, their open directory thing. You could say this serial number corresponds to David McNeely, and when you insert the card in, it would look up in that database, say, this is David McNeely, and again ask you for the PIN. There's a much more stronger authentication happening because an administrator previously has already said this card belongs to David McNeely. Whereas before, all it was saying was this card says David McNeely on it, and you know the pin for it. So
right. So
that was fairly weak. It was convenient, but really it wasn't really intended as very strong authentication. It was much more focused about enabling you to use your smart card for
digital
email,
signing,
those kind of things.
But at least you had, I guess, what you have, the card and a PIN that you had to use to unlock the card, but it didn't translate it in the Active Directory environment. I still don't, in that case, have Kerberos tickets to go gain access to things.
You know, AD might think it's very interesting. You happen to know that
the PIN to the card.
Something about that card, but it doesn't care. It's not interesting in that. What it wants is a user and password. So you could log in, but you would end up without any code. So we actually introduced some time ago support for that mode of operation, where you could just log in using your card, and we actually made some modifications to our software. So you could log in, and we would know who you were, and we would do checks based on our zones and so on. But you didn't have Kerberos credentials, so you couldn't reach out to other Windows services and use them.
So what do we have to do to this to make it tie into Active Directory?
Okay, so over here,
so what we care about.
Right, so over here we have AD, right? So AD is a whole bunch of services, but one of the things you have in there is a service called the KDC, the Kerberos Distribution Center, because at its heart, one of the things that AD is a Kerberos KDC. Kerberos defines basically two mechanisms for authenticating users. The first one is user password. I mean, you don't send a password in plain text over the wire, but various jiggery-pokery goes on, and you end up with one side. This side knows that you know the correct password, and you end up getting tickets. And that's obviously what we use normally. Called PKinit, so, which is actually this is actually the password one is called KInit. So PKinit means using public key to do.
But these are like functions on the wire, right?
Well, KInit is actually the name of a command line tool, and that's why PKinit was given the name. But PKinit is a protocol exchange. There's no actual tool. You can't actually go up to a Unix box and type PKinit. But yes, PKinit is a protocol exchange defined by Kerberos. Some time ago, multiple vendors got together to agree on various standards. So we added to DirectControl, we added the PKinit module. And what the PKinit module's job is to use that second authentication mechanism to actually go. The net effect, what we're trying to achieve is that you end up with some Kerberos credentials in just the same way as if you typed your user and password. So the way that works is that I send over a Kerberos exchange, which goes like so, which is what's called an AS request, which means we're going to the authentication server, and our pre-auth type. Don't worry, this won't be in the exam. You don't have to remember it. In other words, the authentication data that's contained in that request is PKinit. And what that actually means is that inside the message, I include, first of all, a certificate. I include my certificate off this card, which is public information. Certificates are freely available things. They're not secret, even though they're stored on my smart card. So included in this PKinit is a lump of data which includes my certificate, plus a few other pieces of information like I am David McNeely, etc.
It also has my public key, I believe, right?
Well, the public key is part of the certificate.
Right.
All of this is then signed, digitally signed, and the signature is appended to the end. Now, the signature is generated by using the private key. The certificates are all about public key and private key. Again, we could spend many days discussing how those things work, but the private key is held on the smart card, and it will never leave the smart card. So what happens is this module here generates this data block, and then passes it to the smart card and asks the smart card to generate a signature for it. And then the signature that's returned by this thing is then inserted here. So the signature goes here. The signature proves that we have this card
and hold access to the private.
And also the card won't actually do the signature until you've unlocked it using the PIN.
Right.
So it proves that we actually have that physical card and that we know the PIN of the card, and also that the card is for us, because the fact that it's for us is inside the certificate, which is also digitally signed
by the CA.
By the CA. So we pass this entire blob across to the KDC. The KDC can use the public key that's in the certificate to verify this signature. That's the joy of asymmetric encryption. It can tell whether you really did have the private key to generate that signature. And if it's happy with that, and that this username corresponds, so here the other thing it has, of course, is a big LDAP directory here. This is the AD LDAP directory. So I'll look in here to see, do I know somebody called D. McNeely? And if the answer is yes, I do know somebody called D. McNeely. Then I will issue back a TGT. And this will, in theory, go into the Kerberos cache here. Now, there's only one slight problem with that. We haven't quite finished yet. The problem with that is that normally when a TGT comes back, it's encrypted with something derived from your password that you just gave it. Going that way.
So
well, of course, it doesn't know your password now,
right,
because you didn't enter it for you, and maybe you don't even know the password. Even if it did know your password, you don't necessarily know it because you're not using it anymore. You're using a PIN. So it has to use some other mechanism to encrypt the TGT that's coming back. What it wants to do is make sure somebody doesn't intercept this TGT on the wire
to steal it and reuse
to steal it. Right. Well, yes. So it needs to make sure that only you can decrypt it. So it's actually encrypted using, the simplest way of saying it is encrypted using your public key.
Yes, would make sense. That's the one piece.
It's actually not quite as simple as that. In fact, it's encrypted using a different key, and that other key is encrypted using your public key. But effectively, it's encrypted using your public key. So when this comes back, the first thing this module has to do is it goes like this, and this thing again calls the smart card to say, now decrypt this key that just came over, right? And then when the smart card has decrypted it, then it gets written into your ticket cache. So it's actually, the smart card is actually called twice during the process. One is to sign this packet as it goes out, and the second time is to decrypt the TGT encryption key as it comes back in there. Now that we've finished, the rest of Kerberos works the same as it would do before, because we've now got tickets in the Kerberos cache. Everything else behaves just as though you'd logged on using a user and password. It's completely transparent from then on.
Okay. Great. So I think the only other, I get asked quite a few times, how does validation work? And I guess it's because in a lot of these PKI deployments with smart cards, if I were to leave the organization, my smart card is generated and typically is good for 12 months. But if I were to leave in the middle of that, then you've got to terminate my card. Otherwise, the piece of plastic is still good if somebody knows the PIN to it. So somehow the software's got to check to find out that that card was revoked, and that's typically stored in, I guess it gets published to the directory as a CRL. But how does that work in this environment?
I understand what you're asking, but there's actually a much simpler thing going on. Is if you leave the company, you get disabled here.
Yes.
So you've left the company, you don't, AD, I was going to say AD doesn't know you anymore, that's actually not true. In most cases, your account is still there, but it's disabled. So you try and authenticate here, this thing is going to look up David McNeely down here, and it'll say, we have a David McNeely, but he's no longer enabled anymore, so it will simply won't issue anything for you. So we don't even need to worry about,
for the online scenario.
For the online scenario.
Okay, and then there's an offline scenario where if I've already logged on once, it's all cached. I assume this will still let us log on smart card when we're offline.
So yes,
even if I had
that would be a killer piece of functionality, a crushing piece of oversight on our part if we didn't have that killer piece of functionality.
Right, I'm using a MacBook Pro.
Right.
I want to keep using it offline.
Just to recap, today in the user password environment, you can, with our software installed on a Mac, you can log on to that machine while you're sitting on an airplane and use your AD user and password, and it works just fine. And that's because we cache all of the information. We're doing exactly the same as Windows does when you take, for example, your XP laptop onto an airplane and you sign on using your AD user and password, and you do exactly the same as that. But what we obviously need to do is make sure the same thing works in the smart card environment. And in fact, what we do is we fall back basically to the mode that the Mac had originally, which is we can't issue Kerberos tickets because we don't have a domain controller. So all we need to do is make sure that this is a card that identifies you as you, that you know the pin on it. The difference is that we have, where have we got it? Up here, we have a cache, and we will know that there's a David McNeely because you will have previously logged in. So the requirement is that you previously logged in. So when you logged in, we will have up here, there's an entry for David McNeely. So we know that somebody called David McNeely is supposed to be able to log onto that machine, which is a difference from the Apple situation where anybody who knew a user and password could basically, sorry, who knew the PIN number could basically log in. So we know it has to be somebody called David McNeely. The second thing is we know you know the PIN because, again, we challenge you for the PIN when you come in. And we can tell whether you got the right PIN or not, even if we don't try and sign or decrypt things. And then finally, just as we also, in the background, when you first connected, I'm running out of space to draw on here, but we downloaded the certificates that AD used to issue your certificates.
The trusted roots?
The root certificates that we use. So we can tell whether the smart card is trusted by this machine. In fact, I mean, we do that process anyway to tell whether this machine trusts that smart card. And we definitely use that when you're offline to tell whether we trust that smart card.
So if I remember right, that was done at join, and we automatically retrieved out of AD.
Yes, we did that automatically in the background.
Put it into the keychain so that other apps can use it.
Yes, absolutely. And you're right. As a side benefit, it means that all of the applications which also want to have, know the trusted path for any certificates you have, they also benefit from having that. And that's something we just do automatically once you've got our software installed on the Mac.
Okay, great. And I guess on the Active Directory side, since this is a request to log on to Active Directory, if he does any standard CRL or OCSP type checking, that's totally on his responsibility and the domain controller to do that work.
So and he would do it just... So the domain controller is always going to be checking CRLs anyway, the certificate revocation lists, to make sure that none of the certificates that are involved in the whole trust chain have been revoked. It is always doing that. So what that means is that typically this card has been provisioned for use in an AD environment and it's been provisioned by this system, and typically the provisioning system's root certificate is going to be the same because it issued the card, so what's actually been on the card is what it used to issue it. But that's not necessarily the case. There are other deployments. Because
it could have been a third-party CA.
Right, or yes, the card is issued by one environment with a root certificate authority, and this one here needs to know that is actually a trustable certificate. So you need to tell if this machine, if this AD did not issue that card, you need to install there the root certificates of the system that did issue, and that's something you have to do manually to install it in what's called the NT-auth store on AD. Otherwise, it doesn't know why should it trust a particular card that just happens to say this is David McNeely and my PIN is 1234. There's no reason why it should trust that.
Yeah.
So it has to be told that it can trust the issuer of the card, and likewise, it needs to also be told to to keep an eye on by doing CRL checking to make sure that those certificates have not been revoked.
Well, great.
And as completely transparent to the user. That all happens, under the.
Oh, sure. So the user only sees basically insert card and type in a PIN, and then he gets logged on, gets to do single sign-on, sees everything.
Yes, everything works just as they would expect it to. And of course, if you take the card out, the screen will lock and so on.
Yeah.
I don't know if that's a good thing or a bad thing, but it's the thing that it will do.
Yeah, it's actually the policy is selectable for either lock the screen or log the user out, depending on what the organization wants to do. Well, great. Thank you very much. Anything else we need to
I don't think
talk
so.
about?
I think that covers all the necessary.
It does
bits.
too. It's quite a lot to remember. Well, thanks, Paul. That covers the technology and the topics that we wanted to cover this time in the Video Chalk Talk series. This was part 2. Part 1 is available online if you didn't catch that already, and talking about the overall requirements and benefits of this kind of a solution in the customer environments. You can see these Chalk Talks at centrify.com/chalktalks, and look forward to seeing you back for some more. Thank you very much.